Good afternoon to everybody. In this session under Energy Audit Part 1, we cover energy scenario in India and world, energy conservation and its types, and few topics in energy audit. Before knowing these topics, let us know the significance of energy. If you scan through world history, few topics attracted the attention of mankind as much as energy. Nothing has contributed much towards the socio-economic development of a country than what energy has done to the mankind. Nowadays, energy has become fundamental issue for people. It is spreading to every part of life. We depend on energy in some form or other form to fulfill our materialistic needs and essential needs. As per World Economic Growth Survey, it clearly establishes that increased use of energy will lead to increased prosperity of the country. In simple language, how much and how best we use energy resources indicate the level of growth of a country and level of standard of living of people of that country. The demand for energy is increasing at a rapid rate because population is growing at rapid rate and the use of energy is being increasing day to day. Having this much significance for this energy, it is our duty, being engineers, it is our duty to know the world energy scenario and India energy scenario. Gentlemen, you please see the world energy scenario. If you see the world population, 6.2 billion is there. Births per day in the world, 2,22,000 approximately. Population increase every year. You just see, whooping, 81 million. Now let us see the world energy consumption. If you see the world energy consumption, between 1900 to 1965, there is consumption of 600% increase. Between 1965 to 2000, that is in the period of 35 years, there is 450% increase. Between 2000 to 2015, there is an increase of, that is expected increase of 450%. From this, we have to know that within 15 years period, we are expecting very much increase in energy consumption. Now let us see the countrywide energy consumption. You take USA, Western Europe and Japan, they are consuming 60% of world energy. You take Russia, Eastern Europe and China, consuming 30% of world energy. If you take rest of the country, they are consuming only 10% of world energy. India stands at below 10%. You see here, major chunk goes to USA. Now, let us see the world energy sources. In the world energy sources, there are exhaustible resources are there, inexhaustible resources are there. Under exhaustible resources, fossil fuels such as coal, crude oil, natural gas, etc. are there. Under inexhaustible resources, solar, wind, tidal, biomass, etc. are there. Now, let us see the exhaustible resources availability in the world. If you take coal reserves in the world availability, you please see here global coal reserves. There are 1032 billion tons of coal reserves there. USA 25.4%. Russia, they have the reserves of 15.9%. China 11.6%, whereas India 8.6%. So in this, USA stands first and India is fourth place. So we have very good coal reserves. Now let us see the global oil reserves. If you see global proven oil reserves, there are 137 billion tons of worldwide proven oil reserves. Saudi Arabia is having major share 25%, rest of the countries 75%. Now, if you take global natural gas reserves, you please see here, there are 156 trillion cubic meters of natural gas reserves, out of which Russia producing 30%. It is leading producer in the world. Rest of the countries 70%. If you take world average per capita electricity consumption, you see here 900 kilowatt hour per year is there. So there is per capita average electricity consumption in the world is 900 kilowatt hour, that is per head average electricity consumption is 900 kilowatt hour per year, whereas India's stand is very less compared to world average. So I come to this point later on. Now let us see the India's energy scenario. India is having 2.2% of global land and having 1.02 billion population, 16% of world population. So India is having almost all 16% of world population. Let us see India's energy consumption. If you see the energy consumption in India, it is almost all 3% of world energy consumption. If you see that as far as population of India is concerned, it is having 16% of world population, but it is consuming only 3% of world energy consumption. Now let us see the per capita average electricity consumption in India. You see here, per capita average electricity consumption is 367 kilowatt hour per year. Now, let us see the energy sources in India. If you see this, you come to know that there are non-commercial fuels, that is traditional fuels. They are fuel wood, animal waste, agriculture residue. Under commercial fuels category, there are coal, lignite, petroleum products, natural gas, and electricity. Now let us see the fossil fuel reserves in India. If you take fossil fuels reserves in India, coal is having 300 million tons, oil 80 million tons reserves are there, and 30 billion cubic meters of natural gas resources are there. Now let us see the share of energy demand in India. If you take the coal, for meeting energy demand in India, coal is contributing almost all 32% for energy generation. Hydro and nuclear 25%. If you take natural gas, it is contributing 21%. If you take crude oil, 4.2%. So out of this, all this coal is contributing much more for generating power, and remaining 2.5% comes from renewables. Now let us see the share of electricity power generating sources. Hydropower, it is producing almost all 24.92%, thermal power 70.95%, nuclear power 2.52%. So out of these, thermal power is leading, it is producing almost all 70.95% of electricity generation in India. You see here wind and other renewables producing 1.61%. Now let us see the installed power generating capacity. During 1948, we have installation power generating capacity was 1300 megawatts. In 2003, it is whooping 1,07,973 megawatts. So we have achieved an increase of 1,06,673 megawatts in 55 years. In just 55 years, we have achieved this much of generation. Now let us see this table. From this, you come to know the installation capacity as on March 2000 and various power generating sources here. Thermal power, we are producing 61,157 megawatts, diesel, LNG, gas, almost all 11,000 megawatts, nuclear 2,720 megawatts, hydropower 25,116 megawatts. Totally, it contributes as on March 2001, 1,000,010. During the period of 2001-2012, Government of India has fixed the target production in thermal category 53,333 megawatts, and gas, LNG, diesel we have targeted to produce 20,408 megawatts, and nuclear we have targeted to produce 9,380 megawatts, whereas hydro power 32,673 megawatts. So totally we have targeted to produce in these 10 years, that is during the period of 2001 to 2012, 1,15,794. So total capacity as on March 2012, thermal we have targeted to produce 1,14,490 by 2012. These figures are 31,425 megawatts gas, LNG, diesel contribution. We have targeted 12,100 megawatts for nuclear, whereas hydropower 57,789 megawatts we have targeted. Totally we have targeted by March 2012 to produce 2,15,804 megawatts power. These figures are based on 10th and 11th planning projections prepared by the Government of India. So what we have achieved in 55 years, we have to achieve within 10 years. You just imagine how much energy resources we require. But as far as India is concerned, our energy resources, that is exhaustible resources, are fast depleting. And the known oil and natural gas reserves in India are estimated to last within 20 years, and uncertain rains, deforestation have become threat to the hydel projects in India. And also we have the consumption of 60 million tons. We have the consumption of 150 million tons of firewood, but we have the capacity of produce of firewood is only 60 million tons. Where coming from remaining 90 million tons? We are going for forests, so that there is a danger of deforestation, so that we are really in the energy crisis. What we have to do to meet the situation? We have left over very few options. We have the leftover options are, you please here see here, there are energy conservation techniques, effective and efficient utilization of available energy, avoid unnecessary energy wastages, use renewable sources of energy. Now let us know the energy conservation. So what is the definition of energy conservation? Energy conservation is defined as the substitution of energy with convenience. It is also defined as the rational and scientific use of energy. For example, a group of people, if they are sitting in a hall, in an assembly hall. Before leaving the hall, they fail to switch off the fans or lights existed there. So if we do not put off these lights and fans, the power consumed by those fans and lights will be wasted. So that this type of energy wastage we have to avoid. So this is one type of energy conservation. Just I have told an example for this energy conservation. Now let us see the benefits of energy conservation. If you see the benefits of energy conservation, reduction in energy use, improves overall efficiency of the plant, saving the potential energy sources, maximum cost effectiveness in energy use. Reduction in energy use means the conservation technique will be helping a lot the input energy that we have to supply for a particular facility, so that energy consumption for that facility will be totally reduced for the given output. As far as overall efficiency of the plant is concerned, the overall efficiency of the plant also will be improved, because for the reduced energy input we are getting the same output. So the efficiency of the plant also be increased by energy conservation. Saving the potential energy sources also. Saving the potential energy sources. So since we are supplying the less input. Hello?
Hello? Hello, Rana Reddy?
Please.
Just now we have listening your topic.
Yes, yes.
Can we know the important aspect of hydro power generation?
Yes, yes.
So in India, there is a tapping. There is a tapping about 80,000 megawatt energy can be generated.
Yes, yes.
So there is a potential is there. Why we are not unable to tapping that type of the energy?
Because there are uncertain rains, because due to deforestation and uncertain rains, the hydel project reservoirs are not completely to the capacity filled of water, so that we are unable to produce the capacity power generation. That is the main reason. Now let us see the methods of energy conservation in thermal power plants. They are cogeneration, fluidized bed combustion system, improved boiler design, use of non-conventional energy. Let us know in detail about all these methods of energy conservation. Let us see the cogeneration. Let us know the definition of cogeneration. First of all, cogeneration is nothing but combined production of two forms of useful energy from the same fuel. The efficiency of cogeneration is claimed to be as high as 65% to 85%, whereas the efficiency of steam power plant is 30% to 40%. You just imagine the plant which is installed with cogeneration will be producing with 25 to 45 percentage of higher efficiency, so that naturally proportionately the energy resources also will be conserving here. Now let us see the types of cogeneration. Topping cycle, it is one type of cogeneration. Another thing is bottoming cycle. Let us know the topping cycle. In case of topping cycle, fuel is burnt, the power is produced from the burned fuel, and the exhaust will be utilized for process heat. Here I am illustrating one example. You see this figure, you come to know that this is boiler, this is turbine, this is water, this is fuel that we are supplying to the boiler, and air also along with fuel we are supplying. This is exhaust gas after burning the fuel, the exhaust gas, steam outlet coming from the boiler, the steam coming out of the turbine will be led to the condenser, and the steam to process to generator. If you see this figure, in the boiler, water will be heated by the combustion of fuel, and the water will be producing the steam. This steam will be coming through this passage, and this steam will be supplied to the turbine. So when the steam is injected with force on the turbine will be rotated at high speed, so that in turn when the turbine is rotated, the generator which is coupled to the turbine will produce the electricity. So power has been produced. So here fuel heat is supplied to produce directly the energy here, that is electrical energy here. Whereas exhaust gases and the steam that is coming out of the turbines will be tapped to take the heat carried by these two, that is exhaust gas and the steam. This heat will be supplied to the other processes, so that we are conserving the energy by supplying heat for other processes. From this we have to know that the cogeneration concepts have been included in this example what I have cited just now. So power is being produced, and at the same time the heat liberated by the exhaust gases and from the steam will be used for supplying to the processes. So now let us see the bottoming cycle. What is bottoming cycle? In the bottoming cycle, fuel is burnt, the exhaust that is liberated from the fuel burning will be utilized for heating the process equipment. The heat rejected by the process equipment will be utilized to produce the power. So that here in the reverse order we are coming. If we compare the topping cycle with the bottoming cycle, in the bottoming cycle directly we are using the fuel energy, fuel heat energy to produce the power, whereas here we are using initially the fuel energy to heat the processes, and the rejected heat will be utilized to produce the power. Now let us see the bottoming cycle. Here for this also I have cited one example. You see this example again. This is the boiler, this is the turbine, this is water that we are supplying to the boiler, fuel as usual supplied with air, and exhaust gas, steam, generator, and process equipment. You see here, the steam that is coming out of this boiler is supplied to the process equipment, so that in the process equipment the heat carried by the steam will be utilized, and the rejected heat will be supplied to the turbine, and thereby turbine will be producing power as it is coupled with the generator. So that from this we have to know that rejected heat from the process equipment will be utilized to generate the power. Now let us see another conservation technique, fluidized combustion. In fluidized combustion system, fluidized bed furnace will be used. Over the fluidized bed, crushed coal, crushed limestone will be placed, and the air will be supplied from the bottom of the bed of the furnace, so that coal particles and limestone particle will be suspended in the air, so that coal particles will be raised and lowered. In this suspension, the water tubes also immersed. When the coal particles burn, the burned particles will supply heat directly to the water tubes, so that water will be getting heated very fastly. This is totally different from conventional boilers, furnaces, because we are effectively utilizing the fuel here, that is coal. So here we are using the coal in the form of coal particles. Okay. Now let us see the advantages of fluidized bed combustion. This is a higher boiler efficiency, ability to burn wide variety of coals, ability to release large amount of heat, reduced emission of pollutants. Now let us see the improved boiler design. It is also another conservation techniques. So, what are the advantages of improved boiler design? See, the improved boiler design, the efficiency of the boiler can be improved by the following conservation methods: using heat exchangers to recapture the heat discharges, reducing heat loss with better design and control. Now, let us see another energy conservation technique, that is use of non-conventional energy. So, solar energy, you know pretty well, the wind energy, biogas, tidal and others. So, all these energy resources nowadays we are using effectively for saving the exhaustible energy resources. Government is also giving nowadays lot of benefits to the entrepreneurs, the entrepreneurs who produce energy or power, who generate the power using non-conventional energy sources. Now, let us see the energy efficiency. It is the ratio of energy delivered by the generator to the energy released by the fuel in particular period of time. It is interesting to note that in India, though we are consuming less amount of energy as far as world average energy consumption is concerned, we have, this is thermal power plant based on cogeneration. This is another thermal power plant based on cogeneration, this also. Now, let us see the factors that contribute to energy conservation. Increased exploitation of energy sources and economy in their use, and elimination of wastage, and reduction of energy using activity, and optimization for using and replenishing the country's energy source, design updating, use of better process technology. Now, let us see the energy audit. Let us now define the energy audit. According to Energy Conservation Act 2001, energy audit is defined as the verification of use of energy, including submission of technical report containing recommendation for improving energy efficiency with the cost benefit analysis and an action plan in force. It is also defined as the energy activity associated with the plant energy study, energy utilization analysis and the evaluation of energy conservation potential. It is an examination of total energy use in a particular system. Now, let us see the need of energy audit. It helps to understand more about the ways energy and fuel are used in any industry and helps in identifying the areas where waste can occur and where scope for improvement exists. It helps to determine the ways to reduce energy consumption per unit of product output or to lower the operating costs, to utilize our available energy effectively, to identify energy conservation techniques. Let us know the types of energy audit. There are two types: preliminary audit and detailed audit. Preliminary audit can be conducted for less period, that is 1 to 10 days period. So, let us see the procedure of preliminary audit. So, type of energy audit to be performed depends on function and type of industry, depth to which final audit is needed, potential and magnitude of cost reduction. Now, let us see the procedure for preliminary audit. Establish energy consumption in the organization, estimate the scope for energy saving, identify most likely and most easiest areas for identification, identify immediate improvements or savings, identify areas for more detailed study or measurement. So, in this session, what we have covered, let us recollect once again. We have covered significance of energy, energy scenario in India and world, energy conservation, benefits of energy conservation, types of energy conservation. We have detailedly studied the types of energy conservation, and also we have defined, as per Energy Conservation Act 2001, detailed the energy audit. We have also studied the types of energy audit and also need of energy audit. In the next session, we cover remaining topics of energy audit. Thank you, one and all.